day, class. You are welcome back to another section of integral calculus. Here, we are going to treat integration by algebraic substitution. Integration by algebraic substitution. You know, sometimes an integral that is not in the standard form can be reduced to one that is in the standard form by making algebraic substitution. If you have an integral that is not in the standard form that we have treated, then you can actually reduce it to the standard form by making certain algebraic substitution. Now let us take a look at such examples. Now let us look at some examples. Number one here, supposing you are given this integral x exponential x raised to power 2 dx. Like this one, it is not in any of the form that we have treated in the past. Now you are going to use algebraic substitution. Now we say let u be equal to x raised to power 2. Then we now differentiate u with respect to x. We have du dx is equal to, when we differentiate x squared, to give us 2x. You may ask, why don't I say let u be equal to x? Why not x squared? Now, I'm going to tell you the reason very soon. Now, let's move ahead. Then, after this, the next thing here is you make the x the subject of the formula. So, the x is going to be du over 2x. Then, this integral x exponential x raised to power 2 dx will be integral of x e raised to power x squared is u, then the x is du over 2x. So that this x will cancel this x. We now have, this is 1 over 2, bring it out, e raised to power u du. Can you see you have succeeded in eliminating all the x term from this place, remaining only u. Assuming you make u equal to x, we differentiate it, it will give us 1. We will not be able to eliminate this x squared here. For that reason, we will not be able to proceed in our integration. Now, let us continue. Then from here, we have 1 over 2. The integration of e raised to power u is t e raised to power u. Then we put our constant of integration, which is c. Then we now replace our u, which is equal to x squared. Therefore, our integration is 1 over 2 e raised to power x squared, then plus c. Yes, there is shortcut for this one. Let us take a look at the shortcut. The shortcut for this integral of x e raised to power x squared, the x is that you will differentiate the power of the exponent, which is x squared. When you differentiate it, it will give you 2x. Then you use it to divide the function itself. It will now be x exponential x squared divided by the differentiation of x squared, which is 2x. Then you put your constant of integration, so that this will cancel this. This will be 1 over 2 e raised to power x squared plus c. This is the shortcut for this. Now let us take a look at another example here. Example 2. We have integral of x squared cos cube x the x. Now, what are we going to use here now? By default, we are going to use the value of x that has the higher power. Here, we have x raised to power 2. Here, x is raised to power 3. This is how we write it. Don't say it is cos that's raised to power 3, not x. It is x that is raised to power 3. For that, we say let u be equal to x raised to power 3. Then we differentiate the u, the x to be equal to, then this will come here, then we'll subtract 1 from the power. This is x raised to power 2. Then this integral x squared cos cube x, the x becomes integral of x squared cos u. Now from here, when we make the x the subject of the formula here, we have the x is going to be equal to du over 3x squared. Then we'll bring it here to replace the x, which is du over 3x squared. And you see this will cancel this. Then this is 1 over 3. We'll bring it out. Integral of cos u du. Can you see we have succeeded in eliminating x completely by introducing u? Now when we integrate cos u, it will give us sine u plus the constant of integration. Then we now replace our u, which is equal to x cubed, which at the end of the day we have 1 over 3 sine cube x plus c, the constant of integration. Now let us take the third one. We have the integral of x root 1 plus x squared dx. Now we say let u be the value inside the square root, the value under the square root, which is 1 plus x squared. Then when we differentiate u with respect to x here, when we differentiate 1, it will be 0, we throw it away. When we differentiate x squared, it will give us 2x. Then we now have integral of x root 1 plus x squared dx will be equal to integral of x, the root of u, the x here, as usual, the x will be equal to du over 2x. Then now use the u over 2x to replace it. Can you say this x will cancel this x? We are now left with, this is 1 over 2, we bring it out, integral of the root of u du. Then we now rewrite it in a better format that will enable us to integrate it, which is 1 over 2 integral of, the root of u means u raised to power 1 over 2, then du. Then from here we have 1 over 2. When we integrate u raised to power 1 over 2, we add 1 to the power, it will be half plus 1, this will be 3 over 2. Then we divide it by the new power, which is 3 over 2, plus the constant of integration. Then from here, we now have 1 over 2. This one will be times 2 over 3, u raised to power 3 over 2, plus the constant of integration. This cancels this. We have 1 over 3 u raised to power 3 over 2 plus c. Then we have 1 over 3 u raised to power 3 over 2 plus the constant of integration. Then we now replace our u, which is equal to 1 plus x squared. Then we now have it as 1 over 3 square root u raised to power. We now have it as 1 over 3. Our u is 1 plus x squared raised to power 3 over 2. Then we now have it as 1 over 3. here, this one means square root of 1 plus x raised to power 2, then everything raised to power 3, plus constant of integration. Thank you. Now let us take a look at example 4. Example 4, we have integral of x squared multiply 3 plus x cubed raised to power 3 over 2 the x. We say let u be equal to 3 plus x squared. When we differentiate u with respect to x, we have this one as 3x squared. Then our the x will be the u over 3x squared. Then we now have this integral x squared into 3 plus x cubed raised to power 3 over 2 dx will become integral of x squared. The whole of this place is u raised to power 3 over 2. Then our dx is du over 3x squared. So that this x squared will cancel this x squared. We have this is 1 over 3 integral of u raised to power 3 over 2 du. Then we have 1 over 3. When we integrate this will be u raised to power. We add 1 to the power. 3 over 2 plus 1 will give us 5 over 2. Then divide by the new power, which is 5 over 2. Then plus the constant of integration. We have 1 over 3 times 2 over 5 u raised to power 5 over 2 plus the constant of integration. Then 1 times 2, which is 2, 3 times 5, which is 15, u raised to power 5 over 2 plus the constant of integration. Then we replace our u, which is equal to 3 plus x raised to power 3. Then we now have 2 over 15. Our u is 3 plus x cubed raised to power 5 over 2 plus constant of integration. At the end of the day, we have it as 5 2 over 15. These two means square root of 3 plus x cubed then raised to power 5 plus the constant of integration. Now, let us quickly take a look at the last example here we have, number 5. If you are given this integral of x squared into 3 plus exponential x everything raised to power 4 dx, then we say let u be equal to 3 plus exponential x. Then when we differentiate u with respect to x is equal to, when we differentiate 3, it will be 0. When we differentiate e raised to power x, it will still give us e raised to power x. Then when we make the x the subject of the formula, we have du over e raised to power x. Then this integral x squared into 3 plus exponential x raised to power 4 dx will become integral of sorry, here is exponential raised to power x. Is exponential raised to power x. Then here will now be exponential raised to power x. Then we have exponential raised to power x. This place is u raised to power 4. Our dx is du over exponential raised to power x. So that this will cancel this. We have integral of u raised to power 5 du. Then from here, we can integrate easily here. Then to integrate this u, it will be u raised to power 6. Oh, u is raised to power 4. Here, u is raised to power 4. When we integrate u raised to power 4, it will be u raised to power 5 over 5 plus the constant of integration. Then we now replace our u, which is equal to 3 plus e raised to power x. Then we now have it as 3 plus e raised to power x raised to power 5 over 5 plus the constant of integration. Thank you very much. Be expecting another video on integral calculus.